Okay, guys, let's go back over these exponent laws. I want to start with just kind of going back through and showing you. Let me post it here. I'm just going to go back and talk real quick about exponents and how they're set up. So if I have 2x to the third power, and this is on a poster in our room too. I have 2x and then the third. This is my coefficient. This is my base. And this is my exponent. Now, also, and this is kind of what we're focusing on right here, bases and like bases. Like bases can be numbers or variables. And like bases are the same. It would be the same number or the same variable. Like bases are the same number or variable. Okay, so I just kind of wanted to throw those notes back in real quick for you, for those of you that maybe weren't in here yesterday, or just as a reminder. So, taking those, and so let's go over here and look at this. So if you look right here, these are like bases. They all are the same. And here's our, this is the product rule. The product rule is multiplying like bases. Okay? Multiplying like bases. So if I'm multiplying like bases, if you notice here, this would be your 3 to the second power. This would be your 3 to the 5th power. And what do we have? We've got 3 to the 7th power. Okay? This is 2 to the 1st power. So that's going to be 2 times 2 to the 6. 2. 1, 2, 3, 4, 5, 6. So that gives us 2 to the 7th. B to the 5th. Times b to the 8th. Is b to the 13th. So compare the first and third column. Describe using words the relationship that you see between them. So here, what we see here is that the base stayed the same. And the exponents were added. Another way that we say that is keep the base, add exponents. Keep the base, add the exponents. So a to the m times n would be a to the m plus n. All right, so now we're going to do these using the product rule. So the way we're going to write this is it's going to be 2 to the 6 plus 8, And I do like it if you show that, because that just kind of helps keep your brain in check. That just kind of helps keep your brain in check. And so that's going to be 2 to the 14th. Something else that I'm just going to kind of throw out here real quick on a Post-it is for you to keep in mind that -2 to the 3rd power and -2 to the 3rd power are not the same thing. This is the opposite of 2 to the 3rd power. So this would be 2 to the 3rd power is 2 times 2 times 2, which is 8. And the opposite of that is -8. This is -2 times -2 times -2, which is -2. That's a +4 times a -2, which is also a -8. Just happens to be that they're both negative there. But the way that's not always, you're not always going to end up that way. And those two things are not the same. If you want to multiply, if you want the negative to be included with your base, you have to put the exponent outside the parentheses. You have to group them together, which is what's happened right here. So we've got -7 to the 3 plus 1 plus 5, which is -7 to the 9th. This is m to the 1st plus 5 plus 6, which would be m to the 12th. Okay, so that's our product rule. Keep the base and add the exponents. And that's when you are multiplying like bases. Product rule. Multiplying like bases. Okay? Now, the power rule. This is when you're raising a power to a power. So this is also known as the power to a power. For example, you've got -5 squared 3 times. 5 squared 3 times. So here's a 5 squared here. Here's a 5 squared here. Here's a 5 squared here. So that's 5 to the 6th power. 8 to the 5th 4 times. So that's 1, 2, 3, 4, 5 times 1, 2, another one. 2. That's 3, 4. Okay, so what do we have here? We have 8 to the 20th power. This is x to the 3rd 4 times. Okay, so we have x to the 12th. So what is this? What's happening here? We are keeping the base and multiplying the exponents. Okay, so here this would be a to the m times n. Right. So a power to a power, you're keeping the base and multiplying the exponents. Power rule, let's go and write it again. We're going to keep the base multiply the exponents. Keep the base, multiply the exponent. So this is 7 to the 4 times 9, which is 7 to the 36 power. K to the 17 times 2, which is going to be K to the 34th power. W to the 100 times 20, which would be W to the 2000th power. Ooh, big numbers. Okay. And the last one we're going to talk about is the quotient rule. Quotient rule. This is dividing like bases. Dividing like bases. Now, I don't like the way they line those up. So I'm going to come right up under here and do it again and show you how I line them up, okay? So 6 to the 9th. 1, 2, 3, 4, 5, 6, 7, 8, 9. Over 6 to the 4th. 1, 2, 3, 4. Okay, so what's happening here, and the reason this works is because when 6 divided by 6 is 1. So if you look right here, all of those 6s right there, they're not going away. They are dividing into a 1, okay? We're dividing and getting 1. And when we do that, anything that's multiplied by 1 is itself. So when I multiply out all those 6s, make sure I'm not losing you. When I multiply these 6s and then come back and multiply times 1 times 1 times 1 times 1, my answer doesn't change. And so that's why that ends up being 6 to the 5th. But I like to line them up like that so that you can show that division of that 1. All right, so 100 to the 3rd divided by 100 to the 2nd. Oops. That divides into 1, that divides into 1, leaving us that 100. So I have 100 or 100 to the 1st or 100. T to the 15th. 1, 2, 3. Oh, divided by T to the 11th. Excuse me. Sneezing. So that's 1. Show our 1s. I've got a little crooked. I got off. Sorry. Which leaves us T to the 4th. So what was happening here? The base stayed the same. And we subtracted the exponents. So that's a to the m minus n. So down here we have 16 to the 7 minus 3, which is going to be 16 to the 4th. Now look at this one. They tried to throw you off a little bit here, but think of this is just w over 1. And if I multiply those straight across, 1 times w to the 25th is w to the 25th. And this would be w to the 10th. So I have w to the 15th. Let's rewrite that. W to the 25 minus 10. which is w to the 15th. All right, 4 to the third times 4 to the 7th over 4 to the 5th. Well, first, we've got to do this first. So that's 4 to the 3 plus 7 over 4 to the 5th, which is going to be 4 to the 3 plus 7 is 4 to the 10th over 4 to the 5th. Now we've got 4 to the 10 minus 5, which is 4 to the 5th. Okay? We're not going to do this one or the last one. Those are not any that we have to worry about right now. All right, so coming to this. This is pretty much all of them. So the product rule for adding like bases, multiplying like bases. We keep the base. And add the exponents. We're going to keep the base and add the exponents. So this would be h to the 2 plus 6, h to the 8th. Now, on this one, if you have coefficients, you're going to do the multiplication of the coefficients. So that negative 2 and that 7 are going to multiply and give you a negative 14. Okay? Then we have a to the 2nd and a to the 3rd. So we're going to add those exponents, which would be a to the 5th. Then we have b and b, b to the 2nd. Okay? Here we're going to keep the base. Multiply the exponents. So we have x to the 2 times 3, which is x to the 6th. And again here. Now, we got a little bit of extra stuff going on right here too. This is going to be negative 2 to the m. 5 times 2 is 10 times m to the 3rd. So now we have to add those. Negative 2 m to the 13th. The quotient rule. We're going to keep the base. And subtract the exponents. Okay. So again, we're gonna do the division right here first. 27 divided by 42 you can do on the calculator. 27 divided by 42 is going to be 0.64. That's crazy. 0.64. We're just going to go. And then you're going to subtract your exponents. X to the 5 minus 1, which is 0.64 x to the 4th. All right, so I do what's on top first. So that's going to be y to the 4th divided by y to the 4th, which is y to the 4 minus 4, which is y to the 0. Now, if you look down here ahead a little bit, any number raised to the 0 power, it doesn't matter what it is 1. Anything to the 0 power is 1, period. Don't matter what it is. If you got something to the 0 power, it's 1. So the answer there is 1. The negative exponent rule, if you have a negative exponent, it's just the reciprocal. So with a negative exponent, I'm going to flip this over and just show you a little bit what this is. If I have 2 to the second power, that's 2 to the second power over 1, okay? Well, 2 to the negative second power is the reciprocal of this, which is going to be 1 over 2 to the second power. 1 over 2 to the second power. And one of the ways that I just kind of, one of those shortcut ways is take that negative and turn it into a fraction bar and put all of this under the fraction and put your 1 right there. And that's how you set up a negative exponent. But it, we're going to make this a fraction. With a 1 as the numerator. It's a reciprocal. It's really a reciprocal of a power. It's a reciprocal of a power. So look at what we've got right here. We got negative 5 to the x to negative 2 power. So that's negative 5 and 1 over x squared. Okay? So, right here, we're going to do the math first to get 1/2. And then we have k to the 2 minus 5. And this right here is why I've got you writing it like this, because when you start getting those negatives. So we have 1/2 k to the negative 3. And I'm going, just for the sake of things not being quite so wonky, I'm going to do this as 0.5. So we have 0.5 k to the 3rd. Exponent rule. Anything to a 0 power, 0 exponent, anything to a 0 power is 1. And that's anything. They're cleaning the floors again. Is 1. 1, 1. I won't wait. All right, so that's 7 actually, because this is 7 times 1, which is 7, because that's going to be a 1. W times, all right, so this is going to be W to the 8th over W to the 8th, which you know, I mean, look at that. You know that's a 1. W to the 8 minus 8, W to the 0, which is 1. All right, and that's it. That's everything right there in a nutshell. All right, get those notes, and then I'm going to go through here and just work a few of them. What I'm going to do with this, I'm going to do a couple of them just to make sure that you're getting it on here right, and then I'm going to do a key and put it in Google Classroom for you to check it, okay? So, this is the product rule. And the product rule says we're going to keep the base and add the exponents. And then from here, you can put it in the calculator. Some of these numbers are going to get kind of big. I don't care if you don't have all of them in standard form. I just want you to understand the difference in standard form and exponent form. And I want you to see how to put it in the calculator. So to put this in the calculator to get 3 to the 6th power, I'm going to hit, it's going to be 3, and then I'm going to do my little caret key right here, and it gives me my cursor to be able to put in any exponent that I want to put in, and I get 729. Okay? I'm just going to do one of each, and then I'm going to go back and do a key for you for Google Classroom. This is the quotient rule. So that's going to be 6 to the 4 minus 3, which is 6 to the 1st power. Okay. Just keep in mind, too, I don't think it was written over here. Let's go back to this next page for just a minute. And make a note that any number, anything to the 1st power is itself. So x to the 1st power is x. 3 to the 1st power is 3. Okay? Just gotta make a note of that on here. That's not on here, but we do need to make sure we put that on there. So anything to the 1st power is itself, which brings us over here. So 6 to the 1st power is 6. So that's just 6 right there. Okay? Let's flip that over. This is the product. This is power to a power. So here we're going to keep the base and multiply the exponents, which would be 3 to the 8th. Come back over here. 3, my little caret key, to the 8th power. 6,060. All right. And then down here, all right, there is really no rule for these. There's no rule. I like to say if you're adding and subtracting like bases, you have to take the long way. Use your order of operations. Okay, PEMDAS. All right. So, 2 to the 3rd power, 2 plus 2 to the 4th. 2 to the 3rd is 2 times, oops. And we can just put PEMDAS right there to let you know you've got to use the order of operations. There's no rule. So 2 times 2 times 2 plus 4 times 4 times 4. There's no exponent form here. That's 2 to the 3rd plus 4 to the 3rd. There's no other way to do it. So what do you have? You've got 8 plus 64. I'm just doing it on the calculator just to make sure that my brain doesn't collapse on me. Okay, so you're going to finish this, and I'm going to make your key. And that gets our intro in, and I will be back soon.